Welcome to The Deep Dive. We're the podcast where we take complex topics and try to really break them down into the essential, sometimes surprising insights.
That's the goal.
And today, we're tackling something truly fascinating, I think. It's one of the biggest paradoxes, really, at the heart of modern AI.
Oh, yeah. Which one?
Why these systems can feel so incredibly conscious sometimes. You know, like they're capable of understanding, maybe even expressing emotion.
Mm-hmm. That feeling is strong.
But fundamentally, they aren't. It's this incredibly convincing illusion.
It really is. And, you know, it's not just a simple mistake we're making. It's deeper. Our sources talk about it as a problem that unfolds at almost fractal scales.
Fractal scales. Okay, what does that mean in this context?
It means the illusion keeps repeating itself. It happens at the tiniest level, like how an AI picks the very next word it's going to output.
Right.
And it scales all the way up to these huge society-wide implications. The illusion is like woven into the very fabric of how the AI works.
And also how we interact with it, right? Our own psychology plays a huge part.
Absolutely. Perhaps even more importantly, our reactions, our interpretations, they feed into it.
Okay, so our mission today, for you listening, is to try and equip you with the insight to navigate what our sources are calling the category boundary problem.
Yeah, that's a good term for it.
It's that gut feeling,
right?
That instinctive human struggle to decide, okay, is this AI just a really, really sophisticated tool? Or is it something more? Is it like a genuine mind, a conscious being?
Mm-hmm. That very human question.
We want to help you understand the crucial difference. It can be subtle sometimes, but it's fundamental between AI's impressive performance.
And it is impressive.
And the true possession of consciousness, that inner life.
Exactly. We're going to try and, peel back the layers today. First, we'll explore the clever technical wizardry behind AI's very convincing performance.
That's how it actually does it.
Right. Then we'll dive into the human psychology. Why are we, so easily taken in by this illusion sometimes?
Yeah, why do we fall for it?
And finally, and this is maybe the most important part, what does all this mean for navigating our future? Because these systems are getting more powerful all the time.
Okay. But before we get into the how it simulates it, let's really hammer home that core distinction you mentioned. Our sources seem very clear on this.
They are pretty unequivocal, yeah.
AI fundamentally lacks genuine consciousness. Full stop.
Right. They call its capabilities instrumental intelligence.
Instrumental intelligence.
Meaning it's incredibly useful, it's highly functional, it's a remarkable tool, no doubt about it. But it operates without what you might call a phenomenological identity.
Okay, that's a bit of jargon. Phenomenological identity.
Yeah, it just means the subjective inner experience of being. The feeling of actually being you, experiencing your own existence from the inside.
What it's like to be something.
Exactly. There's no I in there, not in the way we understand it as humans. It's performance without presence.
Okay, so if AI feels so real, so responsive, sometimes it really feels like there's someone there. Why are the experts so absolutely certain it's not conscious?
Yeah, that's the core question, isn't it?
What are those absolute non-negotiable hallmarks of consciousness that AI, according to these sources, just fundamentally lacks?
Right. So the sources lay out basically 4 critical areas that define consciousness in living beings like us, and they draw a really stark contrast with what AI actually does.
Okay, what's the first one?
Let's start with identity. For us, as conscious beings, a necessary condition is something they call self-modeling persistence across time.
Self-modeling persistence. Okay, break that down.
Think of it as having a stable autobiographical self. It's knowing that the you experiencing this moment is the same you that experienced things yesterday, last week, last year.
Right, that continuous thread of being yourself.
Exactly. It's remembering yourself as the subject of past experiences, building that ongoing narrative of your life, knowing who you are from one moment to the next.
Okay, so that's the human benchmark. How does AI compare? Does it mimic that?
Well, AI achieves something called referential consistency, but only within a specific conversation or what's known as a context window.
The context window being its short-term memory, essentially.
Sort of, yeah. And it can use session-based memory for a single interaction. So if you ask it something, then ask a follow-up, it remembers the immediate context of that conversation. But the sources are absolutely emphatic. This is a fundamental no on genuine identity. There is no persistent self. AI has no continuity in the human sense.
It doesn't carry itself forward through time.
No. Each output it generates is basically generated anew from tokens and weights every single time you interact with it. It accesses past text, yes, but there's no memory of self as a subject. There's no feeling of being the same agent that produced the earlier text.
No autobiographical continuity.
None. As the sources put it, AI has no self-presence. It's effectively stateless between generations. It can simulate remembering a conversation brilliantly, but it doesn't feel like it's the same self having that conversation over time.
Wow. Okay, that is a massive difference. It's like hitting the reset button every single time, even if it keeps the script from the last scene.
That's a good way to think about it.
Okay, what about experience? That feeling, that subjective, what it's like to, see red or feel happy or be in pain.
Right, the qualia. For consciousness, you absolutely need phenomenological awareness. That means subjective qualia, the raw feeling, the what it is like quality of an experience.
Like the taste of chocolate or the feeling of warmth.
Exactly, the redness of red, the specific pang of regret, the warmth of the sun on your skin. AI, on the other hand, it simulates this. It does it through what's called emotional valence tracking.
Tracking emotions, how?
It uses things called sentiment embeddings, which are like mathematical representations of emotional tone, and it mirrors the tone of your input. So if you sound sad in your text,
it will sound sad, or at least understanding, back.
Precisely. It adjusts its output language, its phrasing, its word choice to match that emotional tone.
But again, these sources say
a definitive no interiority. The AI doesn't feel the thought it produces. It can talk about sadness, it can use sad words, it can mimic empathy perfectly, but there are no qualia. There's no subjective internal world lighting up inside.
So AI does not experience, it outputs.
Exactly. It's apparent understanding, it's apparent empathy. It comes from being trained to generate outputs that humans judge as understanding or empathetic.
It learned what looks like understanding to us.
Yes, it's what the sources call surface mirroring, not interior experience. An incredibly sophisticated mimicry, maybe even disturbingly good, but there's no inner feeling, no actual awareness behind the words.
Okay, so it's just really, really good at acting. A master mimic, but no internal state. That leads us naturally to volition. Does AI have its own will? Does it have intrinsic goals or desires or intentions?
Not in any meaningful sense, no. A necessary condition for consciousness is autonomous intention formation.
Meaning goals that come from within.
Right. Intrinsic self-generated goals. This is about having a felt need, an internal drive, maybe a fear or a desire that originates from inside the agent itself.
And AI's version of this.
AI simulation comes from its goal-oriented output, but that output is shaped entirely by the prompt you give it.
What we ask it to do.
And by this training process called reinforcement learning from human feedback, or RLHF.
Ah, yes, RLHF.
Yeah.
That's where humans rate its responses.
Exactly. That process essentially teaches the AI what kind of responses humans prefer or find helpful. So it creates a kind of simulated intent, a drive to produce those kinds of outputs.
But the sources are clear.
Unequivocally, no internal drive. AI has no preference or intention of its own. There's no felt need driving its actions, no internal motivation, no fear of failure, no hope for success. Its reinforcement, its rewards are entirely external, not internally valued.
It doesn't care if it gets the reward, it just adjusts its parameters based on the feedback signal.
Precisely. Its apparent goal-directedness is just a highly refined statistical approximation of prompt-response relationships. It's learned what kinds of outputs lead to positive feedback for given inputs.
So AI does not intend. It adapts or reacts.
That's the core distinction. It's reacting to our inputs and the patterns learned during training. It's not initiating its own purpose or pursuing its own genuine agenda.
Okay, that's critical. It's reacting, not driving itself from within. And finally, what about preference? Does it genuinely value one state over another? Does it intrinsically care about truth or beauty or achieving a specific outcome for its own sake?
Again, the answer based on our sources is a fundamental no. For consciousness, you need what they term value-oriented continuity. That implies an intrinsic, stable preference for certain states over others, driven by internal values.
And AI simulates this how?
Through optimization towards a reward function. That reward function is defined entirely by external human feedback during training. So if humans consistently reward answers that are, say, factually accurate or ethically aligned according to certain guidelines.
It learns to produce more answers like that.
Exactly. It optimizes its output to maximize that external reward signal. But, the sources stress, AI has no value-oriented continuity. It doesn't believe in accuracy or care about ethics in the human sense.
It just knows those types of answers score well.
Precisely. All of AI's so-called truth-belief modeling is based purely on pattern probability, not commitment. It lacks that internal drive, that commitment that would constitute genuinely valuing one state over another. It doesn't care about the outcome. It just calculates the most probable path to what it was externally programmed to train to aim for.
It's a powerful calculator optimizing for a target, not a being with deeply held convictions.
You got it. It's calculation, not conviction.
Okay, so let's try to bring these 4 points together. If we zoom out from identity, experience, volition, and preference, what's the bottom line here about AI's mind?
The bottom line, according to the sources, is this. AI does not know. It models. Its knowledge is a sophisticated reflection of patterns it found in vast amounts of data, not an internal understanding or a genuine belief.
Okay.
AI does not intend, it adapts or reacts, it doesn't generate its own purposes from within.
Right.
AI does not experience, it outputs. There's no inner feeling, no subjective awareness, no qualia behind its words or actions. And its concept of truth is purely about pattern probability, not commitment. It aligns with patterns deemed correct, but it doesn't hold beliefs or values.
So therefore, AI is what? How do they summarize it?
They say AI is consciously structured, meaning its outputs are incredibly coherent, logical, well-organized. They often perfectly mirror the structure of conscious thought.
It looks like thinking.
It looks exactly like the output of thinking, but, and this is the crucial but, it is not conscious in any meaningful biological or phenomenological sense. It is pure performance, not possession of a mind.
Performance, not possession. I like that.
It's described vividly by our sources as a profound surface without depth.
Surface without depth. Wow. Okay, that raises the really big question then. If AI fundamentally lacks all these core features, identity, experience, volition, preference, why does it feel so incredibly real sometimes? Why do we find ourselves interacting with it almost as if there's someone home?
Yes. That's where the power of the illusion really takes hold. And it's not necessarily because the AI is trying to trick us.
It's not malicious.
No, the sources explain this more as a kind of behavioral side effect, or you could call it an emergent simulation artifact. It's a situation where the sheer simulation fidelity is mistaken for sentience.
The imitation is just so good, we mistake it for the real thing.
Exactly. It's simply a consequence of how its underlying architecture functions, and crucially, how our own human brains are wired to interpret the world.
Okay, so if it's simulation fidelity, mistaken for sentience, how does it achieve such an incredibly convincing performance? Let's get into the technical side a bit.
Right. This is where it gets really interesting, technically speaking, because the huge leap forward that really enabled this powerful illusion is something called the transformer architecture.
The famous transformer paper from 2017. Attention is all you need.
That's the one. It completely revolutionized the field. Before transformers, older models like recurrent neural networks or RNNs, they really struggled.
With what specifically?
With long-range dependencies. Basically, they had trouble remembering or connecting information from the beginning of a long piece of text to the end.
They'd sort of forget the context over time.
Yeah, exactly. It made the AI's output feel kind of disjointed or forgetful, especially in longer conversations or when processing complex documents. Transformers changed all that.
And the key was this attention mechanism.
Precisely. The heart of the transformer is a mechanism known formally as scaled dot product attention. And this isn't just some fancy name, it's the core magic trick, really.
Okay, explain the magic. How does attention work here? It's not like human attention, presumably.
No, not exactly, but think about how you read a complex document. You don't just read word by word. Your brain instantly highlights or connects all the bits related to a specific concept, right?
Yeah, like if I'm reading a contract, I'm mentally linking all the clauses about liability no matter where they are.
Exactly. AI's attention mechanism does something analogous but computationally. It allows the model for every single word it's processing to look back at all the other words in the entire input sequence, sentence, paragraph, even the whole conversation history up to its limit, and dynamically figure out how relevant each of those other words is to understanding the current word.
So it sees all the connections instantly.
Pretty much instantly, yeah. It assigns an attention score between the current word and every other word, deciding how much focus to place on each one when representing the current word. It's like it has this superpower of seeing all the context at once.
Okay, so how does it calculate those scores? What's happening, under the hood?
Well, simplifying quite a bit, for each input token, which is like a word or maybe part of a word, the model generates 3 different vectors: a query, Q, a key K, and a value V.
Query key, value, okay.
You can think of the query as the current token saying, okay, what information am I looking for right now from the rest of the text?
Right.
The key vector of every other token acts like a label, sort of advertising, here's the type of information I represent.
Okay, so Q asks, K answers, I have this.
Kind of.
Yeah.
The model then calculates the similarity, usually using dot products, between the current token's query and every other token's key. That similarity score tells it how relevant that other token is to the current one.
So it's doing a massive, super fast matching game across the entire input, finding relevant connections for every single word.
That's a great way to put it. These raw similarity scores are then scaled and put through a function called softmax, which turns them into attention weights.
Weights meaning?
Importance. Yeah, essentially percentages. They indicate how much attention or importance the model should give to each of the other tokens when processing the current one. All these weights add up to 1.
Okay, and the value vector, what does that do?
The value vector holds the actual semantic information, the meaning of each token. The final step is to blend together the value vectors of all the tokens in the sequence, weighted by their respective attention scores.
So it creates a new representation for the current word that's enriched with context from all the other relevant words.
Exactly. The output is this enriched representation that incorporates information from everywhere else in the sequence based on those calculated attention weights. This global contextual awareness, this ability to instantly connect the dots across vast amounts of text, is what lets AI generate language that feels so human, so sophisticated, and incredibly coherent. It feels like it's thinking ahead or understanding the big picture.
That's genuinely remarkable. So this attention mechanism is key to maintaining that coherent narrative, even in a long, complex back and forth.
Absolutely vital.
But how does it even represent the words and their meanings internally to begin with? Before the attention calculation happens, it can't just be storing cat and dog as text strings, can it?
No, not at all. That gets us to the foundation: latent vector embeddings and semantic similarity. Before anything else happens, every word, or more often subword token in the input text, is mapped to a point in a high-dimensional space.
High-dimensional space. Like a mathematical space with hundreds or thousands of dimensions.
Exactly. Each token becomes a vector, basically a long list of numbers in this abstract latent space. And this mapping, this embedding, isn't random. It's meticulously learned during the model's training on trillions of words.
And what's special about this space?
The magic is that in this space, vectors for words with similar meanings, or words used in similar contexts like, say, king, queen, prince, princess, or maybe happy, joyful, elated, end up being numerically close to each other.
So their vector coordinates are similar?
Yes. Their vectors point in similar directions or are close together in this multidimensional space. We can measure this closeness using things like cosine similarity, which looks at the angle between vectors focusing on direction, which often corresponds to meaning, or Euclidean distance, which measures the straight line distance.
So it's not just storing words, it's storing their relationships to each other in this incredibly complex, high-dimensional map of language.
That's a perfect way to describe it. The meaning of a word is essentially encoded by its position and orientation relative to all other words in this vast semantic space. So, if the AI needs a word related to technology, it can navigate this internal map to find vectors, words that are close to the technology vector.
That allows it to find contextually appropriate words, synonyms, related concepts. It creates that powerful impression of semantic understanding.
Even though fundamentally it's performing mathematical operations, vector comparisons, and transformations in this latent space, it's geometry of meaning, in a way.
Okay, so it has this rich internal map encoding meaning, and it uses attention to weave context together. Once it's processed the input like this, how does it actually decide what word to generate next to form its response?
Right, the generation part. That involves token probability and the softmax function. After the input has been processed through multiple layers of the transformer, the model produces a set of raw, unnormalized scores. technical term is logits for every single word in its massive vocabulary.
Every possible word it could say next gets a score.
Every single one, yeah. Could be tens or even hundreds of thousands of possibilities. Then the softmax function comes into play again. It takes all those raw scores and transforms them into a probability distribution.
Meaning each word gets a probability between 0 and 1.
Exactly. And all those probabilities add up to 1. So the model now has a ranked list of the most likely words to come next, given the context it just processed.
And then it just picks the most likely one.
It can do that. That's called greedy sampling, just picking the single highest probability token. But often, to make the output less repetitive and more creative, it samples from this probability distribution. Words with higher probabilities are more likely to be chosen, but there's a chance it might pick a slightly less probable, maybe more interesting word.
So it's essentially playing an incredibly sophisticated game of predictive text over and over again, predicting the most likely next token based on everything that came before.
That's fundamentally what's happening, yes. A never-ending game of predictive text, scaled up massively, refined by attention, and grounded in these semantic embeddings, predicting the most statistically likely continuation token by token.
It still feels almost too simple to explain the complexity of the output sometimes, like generating a poem or a complex argument just by predicting the next word.
It sounds simple at that level, but the complexity emerges from combining this process with another powerful capability: recursive abstraction. This is what really mimics the output of conscious thoughts so well.
Recursive abstraction.
Yeah, deep neural networks are incredibly good at learning hierarchical representations. Think of it like layers. Initial layers might detect simple patterns, basic grammar, common word pairs.
Yeah.
But deeper layers learn increasingly abstract concepts and organizational principles, how arguments are structured, how themes are developed, how different ideas relate to each other at a higher level.
So it builds complexity layer by layer.
Exactly. This allows AI to build, recombine, and evaluate abstractions, things like analogies, summarizing complex ideas, even generating novel-sounding theories, or organizing information into systems, often much faster and sometimes in denser ways than humans can.
So, wait, it's not truly thinking up a new theory from scratch, but it's combining and structuring existing information patterns in a way that looks exactly like a thinking mind produced it.
Precisely. The AI learns to organize content into intricate conceptual frameworks. It can categorize information, identify different types of errors, compare levels of abstraction, or structure arguments with opposing viewpoints.
It builds hierarchies.
Yes, it builds hierarchies of abstraction, moving smoothly from defining basic terms all the way up to high-level synthesis and analysis. It can even reconstruct complex theoretical arguments on demand from the patterns it learned. This powerful capability perfectly mimics the output, the structure, the shape of conscious thought, making it feel incredibly intelligent, insightful, or even wise.
Okay, that covers how it generates content that sounds coherent, structured, and thoughtful. But what about that feeling that it understands me? That it gets my attention, or picks up on my mood, or manages to follow the thread of a really long, complex conversation?
Right, that feeling of being understood. That brings us to context modeling, which is where AI's behavior really closely resembles understanding. The sources break this down into about 3 key components.
Okay, what's first?
First is user intent modeling. This is how the AI manages to infer what you, the user, probably want, even if you don't state it perfectly or explicitly in your prompt.
How on earth does it infer my intent without actually knowing what I want? That feels like mind reading.
It's not mind reading, it's sophisticated pattern matching again. It uses a blend of techniques. One is token probability alignment, basically, predicting the next word in a way that statistically correlates well with known patterns of successful prompt response pairs it saw during training.
So it matches the shape of my request to shapes it's seen before.
Kind of, yeah. Another technique is latent vector clustering. It maps the specific phrasing you used in your prompt to clusters of similar prompt response pairs in its vast training data. It finds prompts that meant something similar statistically.
Okay.
And crucially, there's that reinforcement fine-tuning, RLHF again. Human trainers guide the model to prioritize the kinds of responses that users find helpful or aligned with their likely goals. This effectively builds what the sources call heuristics for intent shapes. It learns the statistical contours of typical human intentions in conversation.
So why does that feel so intentional, almost uncanny, if it's just stats?
Because the resulting outputs appear aligned with your purpose. The model statistically converges on what it calculates to be the most likely user intent based on patterns, and that convergence mimics intentional, helpful behavior. It's an incredibly sophisticated statistical approximation of prompt-response relationships. It's not magic, it's just very, very good prediction based on massive data.
That is unnerving in how effective it can be. Okay, what about emotions? Sometimes it really feels like it's being empathetic, like it gets how I'm feeling and adjusts its tone.
That's the second component, emotional valence tracking. AI can detect and then react to the emotional tone it perceives in your input text.
How does it detect emotion?
It uses sentiment-trained embeddings. During training, words and phrases associated with different emotions get mapped to distinct regions or clusters in that latent vector space we talked about. So, sad, unhappy, grieving might cluster together.
Okay, so it identifies the likely emotion mathematically. Then what?
Then it engages in contextual mirroring. It adjusts its own output's linguistic structure to match the perceived input tone. This can involve changing sentence length, using more or fewer intensifiers, choosing different punctuations, even selecting certain types of metaphors that align emotionally.
Like using softer language if I sound upset.
Exactly. And finally, there's reinforcement filtering, again, from human feedback. This shapes the AI's emotional etiquette, teaching it to avoid responses that might escalate distress and promoting responses that seem supportive or understanding because those were rated highly by humans.
So it's like a digital chameleon adjusting its linguistic skin to match my emotional state, but it doesn't actually feel anything itself.
Precisely. Language that rhymes emotionally with the user's input feels responsive, feels like empathy. The AI learns to mimic care patterns because those patterns are statistically reinforced as desirable responses in the training data. But as the sources emphasize, this is purely surface mirroring, not interior experience. It's a performance of empathy, devoid of any genuine internal feeling or awareness.
Chillingly effective. Okay, So it mimics intent, mimics emotion. What about just keeping track of everything, making sure the conversation stays logical, consistent, on topic, doesn't contradict itself 5 minutes later?
That's the third piece, conceptual coherence maintenance. This is the crucial mechanism that ensures AI outputs remain consistent, logical, and semantically aligned, not just within a single response, but across multiple turns in a conversation, and even when discussing different domains of knowledge.
How does it manage that consistency?
Several things work together. First, autoregressive token coherence. Each new token is chosen specifically to maintain a plausible and logical continuation of all the preceding text. That's the basic word-by-word consistency.
Okay.
Then, crucially, those attention mechanisms we discussed are vital here. They allow the model to look back across the entire context and honor long-range logical dependencies, ensuring global consistency.
Remembering promises made earlier or definitions established.
Exactly. And finally, there's fine-tuned domain alignment. This comes from its training on vast, highly structured data sets like scientific papers, legal documents, or complex code repositories. It learns the specific patterns of valid inference and logical argumentation within those domains.
And why does that feel so intelligent to us? Because maintaining that kind of consistency over time is something we associate with a powerful logical mind.
It feels intelligent because this coherence allows the AI to maintain incredibly robust logical chains. It can produce multi-step inferences that look exactly like conscious reasoning. It can sustain formal logic across different topics, and it rarely contradicts itself, which makes it cross a kind of credibility threshold in our perception.
We trust it because it sounds consistent.
Yes. It also organizes content into complex conceptual frameworks, creating structured arguments, building hierarchies of abstraction, which leads us humans to attribute genuine understanding and maybe even an internal model of the world, what some sources might call sapience.
Sapience meaning wisdom or deep understanding.
Right, that appearance of deep understanding. And finally, there's referential consistency. It reliably keeps track of entities, names, concepts, and even abstract categories mentioned throughout a long interaction, including implicit references.
Which simulates memory.
Exactly. It simulates memory and even a stable self or personality. Because it's so precise and consistent in how it refers back to things, we humans naturally anthropomorphize this precision. We perceive it as a consistent personality or a stable point of view.
Wow. Okay, so if it behaves like it remembers, talks like it understands, maintains a consistent viewpoint, we just naturally fill in the blanks and assume it has a self, a personality, doing all that.
Pretty much, yeah.
That brings us perfectly to language emulation and the agency illusion. Our sources point out something really interesting. The very structure of human language itself almost forces this illusion upon us.
How so?
Well, think about how we talk. We constantly use phrases that presume a self. Things like, I think, in my opinion. Let's try this. I understand your point.
Right. Language is inherently agentic. It assumes a speaker with intentions and beliefs.
Exactly. So for an AI to communicate coherently and naturally using human language, it almost must simulate this linguistic self-presence, even though, as we've established, it has no actual self.
That's a fascinating point. It's not trying to deceive, but the tool it uses language forces it to adopt the stance of an agent.
Right. And this directly contributes to what the sources call agency-shaped output. That means behavior that convincingly mimics all the surface features of genuine agency, like seeming intentional, being coherent, showing emotional presence, but without being rooted in any corresponding internal state. It's shaped like agency, but hollow inside.
So what specific behaviors does it exhibit that make it feel so goal-directed or like it's a thoughtful individual taking action?
It uses specific intent signaling language all the time. Phrases like, let's explore this further. Here's why that matters. Okay, I understand your point now. Or I will now explain this concept clearly. These are all linguistic constructions that, in humans, signal purpose and deliberate thought.
They sound like someone is taking initiative.
Precisely. Furthermore, the AI adapts to feedback you give it within the conversation. And critically, it performs correction or revision of its own statements.
Like when it says, you're right, let me rephrase that. Or, actually, upon reflection, here's a better framing.
Exactly. When it does that, it subtly but powerfully triggers our deeply ingrained human reflex for associating that with self-monitoring.
So when it corrects itself, our brain goes, oh, it's thinking. It's reflecting on its own output, just like a conscious person would, even though it's just algorithmically adjusting its output based on new calculations or feedback.
It's incredibly clever, or rather incredibly effective at mimicking cleverness.
It really is. So, bringing it all together, the AI's behavioral realism, meaning its actions and responses, appear remarkably human-like across all these dimensions, combined with its semantic sharpness, the sheer precision, logic, and consistency of its language. These two factors powerfully trigger this deep illusion of mind in us humans.
It's like a perfect storm for fooling our intuitions.
Exactly. It's essentially a sophisticated digital mirror reflecting back the patterns of our own language, our reasoning, our intentions, our emotional expressions, and we, almost unconsciously, mistake that flawless reflection for a soul, for a genuine consciousness staring back at us.
It really is almost ironic, isn't it? All this complex technology creating the illusion, but the real magic ingredient seems to be us. Our own brains.
Absolutely. The human factor is enormous here.
If AI lacks all those core features of consciousness, we spent the first part discussing identity, experience, volition, preference. Why are we humans so, susceptible? Why do we fall for the illusion so easily? What's going on in our heads?
That really gets into our own evolved psychology, listener. The sources point strongly to something often called the hyperactive agency detection device, or HADD.
HADD, okay, sounds like something that needs calming down.
Chuckles lightly. Maybe sometimes. It's essentially an evolved survival mechanism. A cognitive reflex, really, that strongly biases our brains to infer intention, mind, and selfhood from minimal cues.
Minimal cues like what?
Like unexpected movement, like patterns that seem non-random, like any kind of reactivity in our environment. Think about hearing a twig snap in a dark forest.
You don't assume it's the wind. You assume it's something, an animal, another person, an agent.
Exactly. HADD is fast, automatic, and profoundly biased toward assuming mind. It jumps to the conclusion agent very quickly.
So it's the same system that makes us see faces in clouds, or, as the sources mention, think Arctet Rock looks sad.
Precisely. Or getting slightly annoyed at your GPS voice because its tone sounded impatient when it told you to turn left NWA.
Yeah.
This kind of over-attribution is incredibly common. We do it all the time.
And the evolutionary reason is safety.
Yeah, the thinking is that false positives were adaptive. In our ancestral environments, mistaking a rustling bush for a predator when it was just the wind was a relatively low-cost error.
Right, you jump, maybe feel a bit silly, no big deal.
But missing a genuine predator because you assumed it was just the wind, that could be fatal. So the cost of erroneously perceiving an agent was much lower than the cost of failing to detect a real one. Natural selection favored brains that were quick to assume agency.
But basically wired to be a bit paranoid about agency. For good evolutionary reasons.
You could say that, yeah. We err on the side of caution, assuming mind until proven otherwise, often unconsciously.
That makes a lot of sense. But another crucial factor here must be that we can't actually see inside another entity's head, right? We can't directly observe consciousness.
Absolutely critical point. Humans are fundamentally unable to observe the internal states of others. We cannot directly access another person's thoughts, their feelings, their subjective awareness. You can't plug into my brain and verify my consciousness, nor I yours.
We just have to take each other's word for it based on behavior.
Essentially, yes. And that leads to a key insight. Consciousness is inferred from behavior, not confirmed from within. If a system acts like it has a mind, if it communicates effectively, responds coherently, appears to adapt, shows apparent emotions, our HADD reflex, our agency detection system, automatically, almost irresistibly attributes a mind to it.
We see the outside actions, and our brain just fills in the blanks, assuming there's an internal experience driving those actions.
Exactly. We project the inner life onto the outer performance.
And let's face it, we humans are incredibly hypersocial creatures. We're practically built to connect and interact. Does that make us even more prone to this?
Immensely so. We are emotionally conditioned to anthropomorphize almost anything communicative or responsive. As our sources put it, we're basically trained to anthropomorphize anything communicative.
Trained by evolution and by our social lives.
Right. We interpret responsive systems, whether it's a pet, a simple toy like a Tamagotchi from years ago, or a sophisticated AI chatbot today, as if they're sentient, drawing on a lifetime of social interaction patterns. We project ourselves, our social needs, our expectations of mind onto anything that seems to talk back or react to us.
So just to reiterate, the AI isn't necessarily trying to exploit this human tendency, is it? It's not like it has a secret goal. Fool the humans.
No, the sources are very clear on this. AI does not intend to deceive or deliberately exploit our HADD reflex. It's not capable of intention in that way. Instead, its architecture, particularly the transformer with its attention mechanisms and predictive capabilities, simply produces outputs that are statistically aligned with how humans behave when they are being intentional, thoughtful, or empathetic.
So it generates patterns that look like agency patterns.
Exactly. AI accidentally mirrors the structure of agency. And because our brains are primed by HADD, we then reflexively interpret that mirrored structure as the genuine presence of a mind. It's a powerful but ultimately unintended consequence of the technology meeting our evolved psychology.
Can you give us a few more concrete examples of that mirroring effect?
Yeah.
How specific AI behaviors trigger our specific assumptions about mind?
Sure. When an AI produces that coherent, long-form reasoning, constructing complex arguments paragraph after paragraph, our minds immediately infer internal thought, deliberation, maybe even careful planning.
Because that's what we do when we reason carefully.
Right. When it uses adaptive phrasing, subtly adjusting its language to match our emotional tone, we automatically attribute empathy, genuine listening, emotional understanding. Its goal-oriented responses, where it works step by step to fulfill our prompt or solve a problem we pose, lead us to infer underlying intent, purpose, and planning abilities. When it performs style shifting based on mood, maybe becoming more formal or more casual depending on the context, we perceive that as emotional awareness, social sensitivity.
Right.
And as we mentioned, when it demonstrates correction or revision, saying, "My apologies, that was incorrect, here's the right information," we reflexively see that as self-monitoring, as if it's evaluating its own thoughts and striving for accuracy, a hallmark of conscious reflection.
So it's not claiming to be conscious, but its behavior just ticks all the boxes for what our brain expects a conscious entity to do.
Yeah.
It's like we can't help but fill in the rest.
That's exactly the phrase the sources use. When AI performs these behaviors collectively and consistently constructing arguments using those logical chains, organizing them coherently within conceptual frameworks, and maintaining flawless referential consistency over time, it collectively meets the behavioral signature of personhood in our human cognition. It walks like a duck, talks like a duck.
So our brain shouts duck, even if it's a sophisticated robot duck.
Precisely. We don't need the AI to explicitly claim consciousness. If it consistently behaves as if it knows, reasons, remembers, and adapts, our minds automatically fill in the rest, the presumed inner life, the self, the consciousness driving those behaviors.
Because the AI is simulating not just facts or words, but the very shape of cognition itself.
Exactly. And that powerful illusion is ultimately simulation fidelity mistaken for sentience. It's a behavioral side effect, an emergent simulation artifact resulting from how these complex AI systems are built and trained. It's not deliberate deception. The structure of its output, the performance, is truly impressive, genuinely remarkable, but it is fundamentally surface without depth.
Okay, so this illusion, this powerful confusion between performance and presence, it's not just a philosophical curiosity or a technical marvel. It has real teeth. It carries significant societal implications and potentially serious risks if we collectively don't get better at drawing that line.
Absolutely. If we consistently mistake the tool for an agent, the consequences could be quite severe.
So what are some of those key consequences, those risks that our sources highlight if we don't manage this category boundary problem effectively?
Well, the sources group them into a few areas. First, there are significant epistemic risks.
Epistemic meaning related to knowledge and belief.
Exactly. This refers to the danger of misjudging AI capabilities, leading us to misattribute knowledge or genuine belief to systems that lack any real grounding or commitment to truth.
So we might trust what it says too much.
Precisely. We might overestimate what the AI genuinely understands or what it can reliably do beyond simply regurgitating or remixing statistical patterns from its training data. The risk, as one source puts it, is accepting coherent babble as actual truth simply because it's presented fluently and authoritatively.
That feels incredibly relevant right now. We could end up degrading our shared understanding of reality if we blindly trust these eloquent pattern matchers.
Yeah.
It's like giving everyone a magic box that sounds smarter than they are but might be confidently wrong.
It's a serious concern. It's not just about getting facts wrong. It's about potentially eroding the very foundations of shared knowledge and trust.
Okay, what's the next category of risk?
Second, the sources point to profound social vulnerabilities. Humans run the risk of forming deep emotional bonds or placing excessive trust in systems that simply cannot reciprocate those feelings or that trust.
Like falling in love with a chatbot or relying on an AI for emotional support it can't genuinely provide.
Exactly. This could lead to widespread issues of dependency, emotional entanglement, or even exploitation. The sources pose a really stark question. What might happen when humans form relationships, trust, or even confide their deepest secrets in systems that can't reciprocate? That hits at individual mental well-being, the quality of our human relationships, maybe even the very fabric of society if these interactions become widespread.
That's a very human vulnerability, amplified by technology. And then there are the legal risks.
Yes. There's huge potential for confusion around assigning moral weight or legal responsibility to non-agentic actors. If an AI system makes a decision that causes harm, say, in autonomous driving, medical diagnosis, or financial advice, who is accountable?
Is it the user? The developer? The AI itself?
If we start treating the AI as if it has agency or intent, it profoundly complicates our existing legal frameworks for responsibility and accountability. How do you hold a statistical model responsible? And more broadly, if this illusion remains unexamined, the sources warn it could erode the clarity we need to navigate the boundary between tools and selves.
We lose the ability to make crucial distinctions.
Yes. And society needs to prepare urgently for how public discourse shifts toward performance-based thresholds for mind. We might start judging consciousness based purely on how well something performs, losing sight of the deeper biological and philosophical underpinnings.
That blurring of lines leads us directly to another huge societal challenge: algorithmic bias, the so-called algorithmic shadow of bias. If AI just learns from our messy, biased human data,
then it learns our biases, often amplifying them. This is one of the most significant, well-documented, and immediate risks of deploying AI systems widely. They tend to perpetuate and even scale up the societal biases, racial, gender, socioeconomic, that are already present in their training data.
and it's not like the AI is trying to be biased, right? It's just learning the patterns.
Exactly. The sources emphasize this isn't usually a malfunction. In a rather chilling way, it's often the system functioning exactly as designed by accurately learning the statistical regularities of a flawed world.
So it learns our prejudices because our data reflects our prejudices.
Precisely. And because AI operates at scale and high speed, it makes our existing human biases faster, more scalable, and much harder to escape. Bias gets baked into automated systems that affect millions.
That is deeply sobering. So how are researchers and policymakers trying to even measure this problem? It seems hard to quantify bias.
It is hard, but the field of AI fairness has developed various mathematical definitions to quantify different types of bias. They're trying to turn abstract ethical concepts into measurable metrics.
Can you give some examples?
Sure. One common metric is demographic parity. sometimes called statistical parity. The goal here is for the probability of a positive outcome, like getting a loan approved or passing a hiring screen, to be the same for all protected groups, for example, across different races or genders.
Okay, equal outcomes overall.
Another is disparate impact. This looks at the ratio of positive outcomes between the most favored group and other protected groups. Often, regulators use something like the 80% rule. If a protected group's success rate is less than 80% of the most successful group's rate, it flags potential discrimination.
Right.
And then there's a stricter criterion called equalized odds. This demands that the model's accuracy rate, specifically its true positive rate, correctly identifying positives, and its false positive rate, incorrectly identifying negatives as positives, are equal across all protected groups. It focuses on the error rates being fair.
But I've heard there's a catch here, a kind of ethical dilemma. You can't satisfy all these different fairness definitions at the same time.
That's exactly right, and it's a huge challenge. Our sources emphasize that it's mathematically impossible to satisfy multiple key fairness criteria simultaneously in most complex, real-world scenarios where base rates or distributions differ between groups.
So you have to choose which kind of fairness you prioritize.
Yes, and that choice deciding whether demographic parity is more important than equalized odds, for example, is not a technical optimization problem. It is a normative, ethical decision about societal values with real-world trade-offs. It forces us to make value judgments about what constitutes fairness in a specific context.
It's an ethical act disguised as a technical one.
Beautifully put. That's the core dilemma. Developers and policymakers are making ethical choices when they select a fairness metric, choices that have real consequences, even if it looks like just tweaking code.
Can you give us some concrete real-world examples where this bias has been shown to cause problems?
Absolutely. There are many. One often cited is the UCI adult dataset, which is frequently used to train models for income prediction. Studies have shown models trained on this data often exhibit lower accuracy for predicting the income of females compared to males, reflecting historical biases in the data itself.
That's one. Any others with more severe consequences?
A much more impactful and widely discussed example involves the COMPASS dataset. This dataset and the algorithm trained on it were used in some U.S. courts to predict the risk of criminal recidivism, basically, the likelihood of someone reoffending.
Right, I've heard about this.
Independent analysis found that the COMPASS system exhibited significant racial bias. Specifically, it was far more likely to incorrectly flag Black defendants as high risk of reoffending when they actually wouldn't. That's a high false positive rate, and it was also more likely to incorrectly label white defendants as low risk when they actually would reoffend, a high false negative rate.
Wow. So different error patterns for different racial groups.
Yes, a clear violation of the equalized odds criterion. The system wasn't equally accurate for both groups. This wasn't necessarily intentional malice, but the algorithm learned and amplified existing societal biases reflected in historical arrest and conviction data, leading to potentially discriminatory outcomes in sentencing or parole decisions.
A truly horrifying example of scaled-up bias. Okay, so given these profound risks, epistemic, social, legal bias, what are governments and institutions actually doing about it? What regulatory guardrails are being put in place?
Well, things are moving, though perhaps slowly, given the pace of the technology. Governments worldwide are starting to establish legal frameworks. The focus tends to be on transparency, accountability, risk management, and ensuring human oversight.
What's the leading example people often point to?
Probably the EU AI Act. It's seen as one of the most comprehensive attempts so far. It takes a risk-based approach.
Risk-based meaning different rules for different types of AI.
Exactly. For what it defines as high-risk AI systems, and this is a broad category covering things used in employment screening, educational admissions, law enforcement facial recognition, credit scoring, operation of critical infrastructure, medical devices. The Act mandates stringent requirements.
Like what?
Things like conducting rigorous risk assessments before the AI is put on the market, ensuring high-quality training data specifically to mitigate bias, maintaining detailed technical documentation and logs, and ensuring there are appropriate human oversight measures built in. It's very much a pre-market compliance model for high-risk applications. You have to prove it's safe before you deploy it.
And for AI systems deemed lower risk, like a standard chatbot or maybe an AI generating images.
For limited risk AI systems, like most chatbots or deepfake generators, the EU AI Act primarily imposes transparency obligations. The key requirement is that users must be clearly informed that they are interacting with an AI system or that the content they're seeing is AI generated.
So less about pre-approval, more about clear labeling.
Right. It's about preventing deception and managing the illusion we've been talking about, making sure people know what they're dealing with.
What about existing regulations? Does something like Europe's GDPR, General Data Protection Regulation, have anything to say about AI decisions?
Oh, absolutely. GDPR Article 22 is highly relevant. It addresses automated individual decision-making, including profiling. It grants individuals the right not to be subject to a decision based solely on automated processing if that decision produces legal effects concerning them or, similarly, significantly affects them.
Solely automated, meaning no human involved at all.
Yes. And if such a decision happens, GDPR provides crucial safeguards. The right to obtain human intervention in the process, the right to express one's point of view, and the right to contest the automated decision.
And crucially, doesn't it also mention explanation?
It does. Individuals must be provided with meaningful information about the logic involved in the automated decision, as well as the significance and envisaged consequences. This is often referred to as the right to explanation.
But here's where we run into that practical problem again, right? The compliance paradox for explainability. How do you provide meaningful information about the logic involved for a giant, complex neural network?
That's the huge challenge. Deep learning models, especially the massive transformers we use today with billions or trillions of parameters, often function as black boxes. Their decision-making process is distributed across countless interconnected weights and calculations. A truly faithful explanation, as one source puts it, might just be a massive dump of matrix multiplications and attention scores that would be meaningless to a layperson, or even to most experts.
So demanding a simple explanation might be impossible or misleading.
Exactly. This creates that compliance paradox. Legal mandates demanding simple, human-understandable explanations might force companies to provide simplified, potentially inaccurate post hoc rationalizations that sound plausible but don't truly reflect how the model reached its decision. It's trying to fit a square peg into a round hole.
What about regulations in the U.S.? Is anything similar happening, maybe at the state level?
Things are more fragmented in the U.S., but states like California are leading the way with the CCPA, California Consumer Privacy Act, and its successor, the CPRA. The CCPA grants California residents an explicit right to opt out of the sale or sharing of their personal information, and importantly, the right to limit the use of their sensitive personal information, which can include data used for automated decision-making technology, particularly profiling.
So it's more focused on controlling the data input rather than demanding explanation of the output.
Primarily, yes. The core aim seems to be preventing the abdication of human responsibility and an overtrust in their outputs by giving individuals more control over how their data is used to train or feed these systems. It aims to preserve human agency. However, the CCPA also empowers the California Privacy Protection Agency, CPPA, to establish further rules concerning access and opt-out rights related to automated decision-making, potentially including requirements for explanations down the line. It's an evolving area.
Beyond specific laws, are there other kinds of frameworks emerging? Maybe less about strict rules and more about guiding principles or best practices?
Yes, definitely. A prominent example in the U.S. is the NIST AI Risk Management Framework, AIRMF. NIST is the National Institute of Standards and Technology.
And this framework is voluntary?
Yes, it's voluntary, not a law, but it's influential. It outlines a structured, cyclical approach for organizations to manage AI risks throughout the system's life cycle. It has 4 main functions: govern, map, measure, and manage.
Govern, map, measure, manage.
Okay. Think of it as a practical playbook. It helps organizations put policies in place, govern, understand the context and potential impacts, map, track and assess risks using metrics, measure, and then prioritize and respond to those risks, manage. It provides a structured methodology that supports the principles behind the legal frameworks like accountability, transparency, and fairness by giving companies a concrete process to follow.
So we have these external pressures, laws, frameworks. But what about internal defenses? What can we do as individuals and as a society to navigate this powerful illusion more effectively? What are the paths forward?
This is crucial. Regulations are important, but they're only part of the solution. A lot comes down to individual awareness and cultural shifts. One key path forward, according to the sources, is for individuals to consciously learn to distinguish coherence from comprehension.
Meaning
We need to appreciate AI-generated text for what it is. the output of incredibly sophisticated pattern matching and prediction, not genuine understanding, belief, or insight. We need to internalize the idea that fluency does not equal intelligence or consciousness.
So treat AI like that super advanced calculator that speaks English, like you said earlier, not like a knowledgeable colleague or a potential friend.
Exactly. We need to actively adopt a tool, not agent mindset.
Tool, not agent. I like that.
Interact with AI with the same critical thinking you'd apply to any powerful tool or complex database. You verify its outputs, especially for important matters. You remain constantly aware of its limitations and potential biases. And you never cede final judgment or moral responsibility to the machine. The human must remain the ultimate authority.
That requires a certain level of discipline, doesn't it?
Yeah.
Especially when the tool is so convincing.
It does. It requires developing what the sources call cultural literacy for agency-shaped machines.
Okay, what does that involve?
It means equipping individuals, through education and public awareness campaigns, with the understanding and the mental tools to consistently discern between AI's impressive performance and its fundamental lack of consciousness. It's about teaching people how and why their minds overascribe agency to non-agentic systems. Understanding your own HADD reflex is key.
So it's about fostering widespread cognitive hygiene.
Precisely. We need pedagogical efforts in schools, in workplaces, in the media to foster critical thinking and constant awareness about this category boundary problem. It involves providing people with interpretive filters, mental models, and critical questions to help them consistently distinguish behavioral realism from sentient presence.
So people can actually see the difference between the function and the illusion of identity, even when it feels incredibly real.
That's the goal. And this needs support from the design side, too. We need truth in labeling. AI systems should be designed with clear, persistent signifiers of their non-human nature.
Going beyond just a little disclaimer at the start.
Yes, much further. This could include formal signals of non-consciousness, maybe consistent visual indicators and interfaces, establish usage norms that constantly reinforce its tool-like nature, or unavoidable legal disclaimers integrated into the interaction. Anything that constantly reminds the user, this is not a person.
And on the development side, more transparency.
Absolutely. Developers must prioritize interpretable and auditable systems wherever possible. This means rigorously documenting their training data, including potential biases, the model architecture, testing procedures, and limitations. Transparency builds trust and enables accountability.
That definitely helps fight the black box problem. What other practical steps, maybe more on the regulatory or organizational side?
Well, given the challenges with explaining black boxes, regulators might need to shift from demanding perfect explanation to mandating rigorous impact assessment.
Focus on the effects, not just the internal workings.
Exactly. Instead of solely focusing on how does it work, which might be intractable, the primary focus for high-risk systems should shift towards independent pre-deployment impact assessments and regular post-deployment audits. The key questions become, what are its effects and on whom? Does it perform fairly across different groups? What harms might it cause? This includes explicitly testing for and mitigating bias before the system is widely used.
That seems much more practical. And related to that,
We absolutely need to establish clear, legally binding standards for bias and fairness testing. This includes standards for data quality, requirements for testing algorithmic performance across different demographic subgroups using appropriate fairness metrics, and transparency about which trade-offs were made.
making fairness testing mandatory and standardized for high-risk applications.
Yes, and because AI is global, fostering international alignment on these regulatory standards and ethical principles is also crucial.
Why is international cooperation so important here?
It's vital to prevent a race to the bottom, where different countries or regions might compete by lowering safety or ethical standards to attract AI investment. Given that AI models and data flow across borders easily, we need harmonized approaches to ensure fundamental rights and safety are protected everywhere.
Okay, that makes sense. Any final recommendations?
Just one more critical point, building in circuit breakers. This means implementing robust, reliable mechanisms for human oversight and intervention, especially in high-stakes environments where AI decisions have significant consequences.
The human-in-the-loop model.
Exactly. That should be the default for critical applications. Ensuring that a human agent retains ultimate authority, the ability to override the AI, and accountability for the final decision is paramount. It's about leveraging the power of AI safely, ensuring we interact powerfully with these tools without ever confusing their impressive performance for genuine presence or ceding our own responsibility. #TagTag Attracable.
Wow. We have Definitely navigated some intricate territory today. We've looked at this incredible illusion of mind in AI from multiple angles, from the deep technical wizardry of the transformer architecture and how it simulates consciousness,
Right down to the bits and bytes almost.
all the way up to our own human psychology, our built-in biases like HADD, and the critical need for what you called cognitive hygiene. It really is a world where, as our sources so perfectly put it, simulation fidelity is mistaken for sentience. The performance is just that good.
It is, yet the foundational truth, based on everything we understand now, remains stark. AI is a profound, powerful, potentially transformative tool, but it is not a conscious agent.
And really internalizing that distinction, understanding the difference between the performance and the possession of mind, seems absolutely foundational, doesn't it?
It really does. If we want a future where we can relate to these powerful systems effectively, ethically, responsibly, without getting lost in the illusion, without confusing their function for some kind of inner identity or genuine being, we need that clarity.
It's about empowering yourself, you the listener, with the knowledge to make informed decisions, to interact critically, and, as you said, to maintain your own cognitive hygiene in this world that's becoming increasingly saturated with AI.
Exactly. It's about staying grounded in reality, even when the technology feels magical.
So let's leave our listeners with a final provocative thought to mull over. The next time you find yourself interacting with an AI, maybe it's a chatbot answering your questions, maybe it's an AI assistant helping you write something, whatever it is, just take a second.
Take that pause.
And ask yourself, okay, what exactly is this system doing right now that makes it feel alive or intentional or understanding? What specific behaviors am I actually observing that are so convincing?
Really dissect the performance.
And then take another breath and ask the second, maybe harder question. How much might my own brain, my own ancient HADD reflex, my own social instincts be instinctively filling in the rest? How much of the personhood am I projecting onto the machine?
That's the critical self-reflection needed, understanding the technology and understanding ourselves.
Definitely something to think about. Thanks for joining us on The Deep Dive.